Alright, well this is day 25, last day, and as always, let us hope that it goes well. In previous years, day 25 has been pretty easy. In fact, one time it was only one part, and the second part was a free part. But you never know what to expect. Maybe they'll make it extra hard. Either way, we'll do it. And today, I'm going to read the problem carefully, unlike the last couple of days, and hopefully it will work. Yeah. Finally reach the check-in desk. Over the registration systems are currently offline. They cannot check you in. Noticing the look in your face, they quickly add the text board is already on the way. They even created all the room keys this morning. You can take yours down and give them your room deposit once registration comes back online. This room is a small RFID card room is on the 25th floor, and the elevators are also temporarily out of service, so it takes what little energy you have to even climb the stairs and navigate the halls. Finally, reach the door to your room, swipe your card, and beep, the light turns red. Examine the card more closely to discover a phone number for tech support. How can we help you? It sounds like the card isn't saying the right command. If you go back to the check-in desk, surely someone can reset it for you. Blah, 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 blah. I see. Well, reverse engineer the cryptographic handshake and check your own commands. That's definitely impossible. Fortunately, if you already know a thing or two about cryptographic handshake. The handshake used for the card and door involves operation that transforms a subject number. Transform a subject number, start with value 1, then a number of times called the loop size, perform the following steps. Set the value to itself, multiply by the subject number, set the value to the remainder after dividing the value by this. The card always uses a specific secret loop size when it transforms a subject number. The door always uses a different secret loop size. Cryptic handshake works like this. Card transforms a subject number of 7 according to the card's secret loop size. The result is called the card's public key. The door transforms to number 7 according to the door's secret loop size. The result is called the door's public key. The card in the door uses a wireless RFID signal to transmit the two public keys to the other device. Now the card has the door's public keys and the door has the card's public keys. Because you can eavesdrop on the symbol, you have public keys for neither device's loop size. The card transforms the subject number of the door's public key according to the card's loop size. The result is the encryption key. The door transforms the subject number of the card's public key according to the door's loop size. The result is the same encryption key as the card calculated. If you can use the two public keys to determine each device's loop size, you have enough information to calculate the secret encryption key that this will allow you. For example, suppose you know that the card's public key is this. I'll try an area where the card's loop size must be 8. It's transforming with the loop size of 8. And the door's public key is the same price At this point, you use either device's loop size with the other device's public key to calculate the encryption key. Transforming the subject number with a loop size of 8, same encryption key that. Transforming the same encryption key. What encryption key is the handshake trying to establish? Okay. Handshake involves number of times called the loop size. So class handshake so let's just say def handshake it transforms the subject number. So loop size, which is an int, subject number, which is an int, is going to return an int. So for blank in range loop size, and so value equals 1, value equals value times subject number, mod 2020 12 27. So return value and so cryptographic handshake works like this. Card transforms to number, card secret loop size, cards, okay. and the subject number is always 7. So I'm just going to say equals 7. Okay, and so now choosing the card's public key, you can work out that the card's loop size must be 8. So let me actually not do it this way. Let me say I am going to, from typing import iterator, and let's say handshakes is going to be an iterator of ints. If I equals 1, and let's say while true, value let me say yield value, and value equals, okay, so now we have a bunch of handshakes, and let's say find loop number using a public key, which is an int, and subject number, which is an int, equals 7, and that's going to return an int, and import iter tools. For in and zip iter tools dot count. Actually, you know what? I don't even need to do that. For in enumerate handshakes of the subject number. If n equals public key, return I. And then I'll just raise a runtime error. I can't get here. So assert that find loop number for this is 8, and assert that find loop number of this is 11, and that works. And now at this point you can use either device's loop size with the other device's public key to highlight the encryption key, transforming the subject number of the door's public key with a loop size of 8. What encryption key is the handshake trying to establish? So let me get this, and let's just see if so let's say door key equals this, and what was the other one called? Card key equals this. Door number equals find loop number door. Key card number equals find loop number card key, and then print and let me just say deft handshake loop number, which is an int, subject number, which is an int, equals 7, and that's going to turn int for in and enumerate handshakes subject number. If I equals loop number, return n. And okay, so print handshake of door number card key, and let's just print this one to make sure that they're equal. Handshake of card number door key. Let's try this and see if it runs. 296776. Continue to part 2. Essentially, the door was off. He's locked in the bed. The pager was off. It's an emergency. The soft start machine just failed. The only one knows how to fix it. We dispatched a reindeer. He has done the host landing on your balcony. The reindeer can fix sports the content in your room. We fed her to pay the 50 stars. Sorry, blah, blah, blah. You have enough stars to pay the deposit. Congratulations. You finished every puzzle in Advent of Code 2020. Alright, that's it. That's the Advent of Code. That was not too bad. So what I did is, just to make my life easier, I used, and I don't actually need iter tools, but what it says is it wants me to do some operation like a number of times, right? And so, and in particular, some of the time it wants me to do it that many times, sometimes it wants me to figure out how many times it will take to do it. So, one way to do that is to just do the operation an infinite number of times and just give back the results. So here, I just do this operation an infinite number of times, basically. And then to actually do the handshake, it wants me to do it, loop number of times. So I just loop over it and, return another way to do this would be it equals handshakes subject. This way is fine. So I enumerate, so I get 0 and the 0th one, 1 and the 1th one, and then as soon as I get to the actual loop number, I return n. This raise runtime error is just because to make the type checker happy, like basically I'll never break out of this loop, but the type checker looks at the this code and says, if you break out of the for loop, even though you can't, you don't return anything. So I just stuck that there. And then similarly, this is the other direction where I want to find the loop number that equals a public key. So now again, I do the iterating, but now instead of checking if the index equals something, I check if the result equals something and return the index. So these are kind of like the duals of each other in some sense, right? Iterate over my infinite list till you get to a certain index, return the value. Iterate over that same infinite list until you see a value, return the index. And then literally I just did what they said. So that's it. That's the Advent of Code. That might be the last you see of me until next December, unless I make some videos of me playing the piano, or unless I come up with some other good ideas, which I probably won't. But in the meantime, you can always follow me on Twitter at Joel Grus. And keep an eye on the YouTube channel. Maybe I'll post something, maybe I won't. But that's that. That's the Advent of Code. That's 2020. Have a Merry Christmas and take care.